Okay, today we got a request to size the height of the flaw. So before we start, I want to go over a couple of formulas that's going to help us keep us in the right path and keep us in the right frame of mind. And that one will be the sound path for the thickness of the material. So I don't have a test block with me at home, but I do have my calibration block. And what I've done, we're going to be shooting this little notch here on the IIW block. And I've marked, just for reference, I marked a line down here that's 1 inch down from that. So we're going to pretend this is a 1-inch test plate. And so the formulas that we're going to need, which I conveniently have stored in the cover of my calculator here. To prop that up, see if adjust this lighting a little better. Okay, so the formula we have is a two-part formula, I guess. It'd be a cosine of the angle, and in this case we're going to be using a 70-degree transducer wedge. You can see it backwards there. So we use a 70-degree wedge, and we're going to need to know the sound path for that first leg. And it's important to know the sound path for the first leg. So let's go write these formulas down first. So we have cosine of angle. And so the math works out to be 0.342 on that. And then the next one, we have the first leg. Sound path, which is the thickness of the material divided by cosine of the angle. All right, so we know this is 1 inch of material divided by 0.3420. So take this calculator. 1 divided by 0.3420. Oh, I did that wrong. So 1 divided by 0.3420. 2.92. So we know the sound path of a 1-inch material is 2.92 inches. So if we're shooting a test block, let's see if I can block on my hand here. So if we're shooting a test block, here's a little test block or a little plate. Here's our transducer. From the math, we know the sound path as it comes out of the block is 2.2 or 2.92 inches. And it's important for us to know that, because if we get a signal that's, say, further out, say if it's like 2.95 or into 3 inches, we know that it's bouncing on the second leg somewhere and not within the first leg. So when we're sizing the flaw, right, we've got a flaw in here, we gotta remember which leg we're in, because if we get something that's way over here and outside of that flaw area, then it's going to give us a misreading of this flaw size. So let's get onto the machine and let's go from there. We got this IW block here. We're going to shoot this notch. Let's see if I move the camera this way a bit. So I got my machine set up with a trig function. This is for surface distance, this is for sound path, and this is for depth. Throw a bit of couplet on. And as we're shooting this, there's indication there in that first leg. And so what I've done on the machine itself too, some of the machines, I think most of the digital machines would be able to do this. You set your evaluation to match the thickness of material. In this case, we're doing a 1-inch thickness. And then we're turning the color legs on, which is this guy here. And so that's why when you see on my screen, I got a yellow, I got a gray, and I got a, I don't know what you want to call that, a baby blue, teal. And those represent the legs, first leg, second leg, third leg. So I'm only interested in the first leg stuff. So I'm gonna turn my screen into a 5-inch screen, give you some magnification on that. And so as I'm moving forward on this one, and see how it drops off. So look at this and the drop off. So I could say this is pretty much, it's gone. I don't see it on my, I see it here, but it's not breaking my gate. But if I move it back to where it breaks my gate at the 50% level, we know that thing is 0.474 inches down. Let's see how correct that is. I'm gonna take my tape and see if I get these things to balance. Nope, so this thing is about 5/8 deep. So we should be able to see it some more on this. May have to move my, either move my, look at that signal. Bump this thing back up. Oh. There's my half. So I'm gonna bump it up and see, take a reading on the gate. I'm breaking gate in 2 places. So I should still be able to read it at 0.625. Bump my gain down a bit. Should be at 60 for reference. Okay, so it's gone at 6.5. In the corner there. So I was to map it out. I would call this thing at, starting at, let's see, where does it go back? I'm gonna go back, that's gone, okay. So 0.6690 depth. And then I'm gonna follow it up. So now I know it's 0.690 depth. I'm gonna follow it until, moving it forward until it disappears. In this instance, it's not gonna disappear. And this is back to what I'm shooting. I'm shooting this notch here, guys. Let's see if we move this over. There it goes. I'm gonna move that until it falls off the screen. And it shouldn't fall off the screen because we know it's a flat notch. Or it's a big reflector. And it's not gonna fall off, it's gonna keep going, and that's it. It's gone. I'm off the end of the plate. And there it goes. It's right at the beginning. So we could mark this one as 0, which is surface breaking, to 0.690. Let's see if we get the repeat. Yeah, I call it 0.690. And so what's important while we're doing that too, we pay attention to our surface or our sound path. Make sure we're not out of that sound path. So if we go into the 2-inch mark, say it disappears, it's gone. If you get the signal way over here, then you know it's outside the first leg, and you can't really, so if it's in the second leg, then you want to continue the size on the second leg. You don't want to size it on the second leg and the first leg. That's where it kind of throws it off. You want to make sure that you got the boundaries clear on that. If you're on first leg or second leg. All right, hope that helps. If you got any questions, shoot me an email, and we'll go from there. Thank you.